main title or logo along with the buttons that lead to different screens in our app. So as you can see, we have 4 buttons: chemical reactions, profession information, the Haber-Bosch process, and about us. And at the bottom, there's like a little additional information of when we started making this app and who we are. And we are chemical engineers of 10 St. Lucie. So to start, we'll go to About Us, and I'll be passing the mic over to Nicole.
Hi. Okay, so About Us. ChemFlow is an educational app that explores the real-world impact of chemical reactions. Using the Haber-Bosch process as a central example, it explains how chemical engineers safely design and scale essential industrial processes. So, meet the team. Okay, starting with our leader, Jairina H. Linglasa. She is our lead MIT app inventor, programmer, content researcher, and the most beautiful, Nicole Gutierrez, is me, a visuals illustrator, app designer, and programmer. The next is Tatiana Bautista, same as my role, visuals illustrator, app designer, and programmer. And the last is Anya Villafuerte. She is the lead MIT app inventor and content researcher. And back to the menu, we go to chemical reactions.
What are chemical reactions? Chemical reactions are processes in which one or more substances are converted to one or more different substances which are products. They happen when atoms rearrange. Indicators of chemical reactions include the following: evolution of gas, change in color, change in temperature, production of heat and light, production of sound, and formation of precipitate. Chemical reactions usually start with reactants and end with products. So you may be wondering why we have this part in our app. We know that actually we developed ChemFlow as an educational app, and since it all talks about chemistry and connects it with our profession, we wanted to start with introducing the concept of chemical reactions first to the user or to the audience. What are chemical reactions in daily life? One example is food spoilage, and another is cooking. Other examples are also digestion and rusting of iron. Chemical reactions in chemical engineering. Chemical reactions focus on scaling chemical reactions up by designing industrial processes that produce chemicals safely, efficiently, and economically. So in summary, they make reactions work in factories, and these are their key questions. How do we run this reaction at industrial scale? How do we control temperature, pressure, and safety? How do we design reactors and optimize yield? And lastly, how do we separate and purify the products?
Now that we're done with the chemical reactions, we'll be connecting it to our profession, which will go here in the profession information button. And as you can see here, okay, now what is a chemical engineering? A chemical engineering specializes in scaling up chemical reactions and physical processes from the laboratory bench to full industrial production. Next, this is the real life application. Now we are able to make gasoline, designing batteries, creating biofuels and hydrogen. Now for the food and drinks, they are able to process food such as milk and snacks, creating flavors and purifying water. And another thing is for the materials, we can create plastics, fertilizers, textiles, and semiconductors and composites. Now we'll go back to the main menu. Okay.
Okay, now we'll be moving on to the Haber-Bosch process screen. So this is the main focus of our app because our app is to educate the user on the Haber-Bosch process and how it connects to our profession. Okay, so this page and the next pages after this are focused on the scaffold information which we answered a few weeks ago. So our profession, chemical engineer. Our chemical reaction is the Haber-Bosch process. Our reactants are nitrogen gas and hydrogen gas. And our product is ammonia. Then we have the evidence of chemical reaction, which is the release of heat. This is explained by when ammonia forms the nitrogen and hydrogen bonds, the formation of these bonds releases a huge amount of energy, and so this excess energy comes out as heat. Now the balanced chemical reaction is here. So yeah, it is balanced because both sides are equal to 6 when you do the solution. Then the type of chemical reaction is synthesis because two different elements, nitrogen and hydrogen, join together to form a single compound, ammonia. Impact. Its impact to life can be positive or negative, and negative. So ammonia can act as a fertilizer, which results in more food production and sustains life. But it has a negative aspect, which is how ammonia is toxic. It can irritate eyes, skin, and our respiratory system. Now, for the environment, it can also positively affect it. So the proper use of fertilizers can maintain soil nutrient levels, supporting ecosystems in farmlands. It can also contribute to chemical production. Now, for its negative impact, ammonia leads to nitrogen accumulation or pollution that can be toxic to animals. Now for the processes, factors, and explanation. So high temperatures are used to facilitate the reaction because as the temperature increases, the rate of reaction, but the rate of reaction also increases, but the yield of ammonia increases. Another is pressure. High pressure is used to increase the rate of reaction. It is high to ensure efficient conversion of nitrogen and hydrogen to ammonia. It also increases the concentration of reactants, leading to more frequent collisions between them, which enhances the reaction rate. Lastly, we have catalysts. The Haber process primarily uses iron as a catalyst, which is essential for speeding up the reaction. So a catalyst acts as something that speeds the reaction up by lessening the activation energy so that the reaction rate is faster. This can be seen in the chemical reaction where there is the element symbol of iron above the arrow. After the scaffold information, we have additional information about ammonia. I'll just skim through all of this. It explains how ammonia is produced and what it is used for. And it has a picture of a visual, like additions thing for the viewer to really understand our point. And we have safety measures, of course, to make sure that nobody gets hurt when they like to study this process. So key safety measures include proper ventilation, PPE or personal protective equipment, pressure-resistant equipment, strict control of ignition sources, emergency eye wash stations, and gas leak detection systems to ensure safety. We have our profession connection to really solidify that bridge between the reaction and our profession. It is a cornerstone of chemical engineering because it shows how a laboratory reaction can be scaled up into a safe, continuous, and efficient industrial process. And that is all. We have our videos, which can be shown here, which explains the Haber-Bosch process. You can show it in simulations and in drawings and animations. Okay, I think we're done with everything now? Yeah. Okay, that's all of it.